First of all, of course, thank you everyone for joining for our another webinar about a Zabbix and a very specific topic, high availability for the Zabbix server and a proxy um, dedicated for the version like 7.4. But basically, this question, like high availability, it's a very popular and a lot of people want to learn what are the best practices and how to correctly configure high availability on Zabbix, making sure that you don't have a single point of failure. And just to give you like a little bit of introduction of who I'm actually am here to tell you about what are those best practices, how you should configure high availability on a Zabbix. Some of you already know me. If you do some research online and try to search how to do some stuff inside a Zabbix, how to configure something, and so on, very likely that you have found one of my YouTube videos about a Zabbix tutorials. I have like 150 something of them already available for all of you for free on a lot of topics, different Zabbix versions. So if you are not aware, go and search. I'm sure that you're gonna find a lot of value for you. Additionally, to all of those numerous Zabbix video, I've also happens to be worked in a Zabbix company for like 9 years. I was support engineer, trainer, consultant, head of customer support, head of product, seen a lot of use cases, a lot of industry monitoring requirements cases, different solutions, and high availability is definitely like one of those because especially whenever we talk about some businesses where the downtime of the service means impact on your business and potentially loss of money and bad quality of the service and unhappy customers and so on. So those type of companies and people always want to be fully aware of everything that is happening in their environment. And Zabbix makes sure that happens. And that's why it's important to make sure that your Zabbix runs 24/7, no matter what. And that's exactly the topic for today's webinar. Rules are, as usual, all of your microphones are muted. If you want to ask some questions, and I hope you do, feel free to do that in a question and answer section. Make sure that you use a chat just for some random discussion, networking, applause, or whatever other generic talks. But if we talk about the questions, let's try to keep them in a Q&A section. I will probably answer like at the end of the webinar, not during the topic, so that we don't have all sort of random interruptions. And if we get started, like high availability considerations. And there's a lot of the questions that we need to think about whenever we decided that okay, we we need a high availability. And I think it's definitely like not for everyone. I do understand the typical use case when there is a company and in the company there are some management people and there are some engineers who are responsible for the monitoring and there are also some trendy words like high availability, AI as example nowadays. And sometimes management give engineers some specific tasks without a lot of the context. And high availability can be definitely one of those. But it is important to understand like what exactly we're trying to achieve because setting up high availability on your solution is not some kind of magic pill that will make all of the problems go away. Just setting up high availability doesn't mean that that's it. You will not have any downtime. Everything is going to be awesome. Your Zabbix is going to work 24/7, 365 days in a year. Because setting high availability is of quite a complex thing to do. And it's also worth to mention, like, since I'm making these videos for the last 7 years, I've been so many times asked to make a video about how it is better to set up high availability on the Zabbix. I always was trying to avoid that because the thing is that if high availability is set and configured by someone who doesn't really understand what he's doing, and is just copy pasting some random commands from the blog post or from the video, it is very likely that the result is actually going to be, if we measure result and availability of the service, it's very likely that it's going to be worse than just a single healthy standalone installation of the Zabbix. And the important thing is also there's like no one type of tutorials applicable for every use case, for every company, every architecture, network architecture, and so on. So it's always important to understand what exactly we need and why we need, which comes to considerations of architecture of our high availability cluster. As I said, like today we're talking mainly about a native tools of the Zabbix that offer you a high availability. If we talk about some not so long history of the Zabbix, there was no native built-in high availability tools, and people had to deal with all sort of custom Linux components like PCS, Coruscant, virtual IP addresses, database clusters, and there's all sort of different use cases that we need to keep in mind. And especially if we talk about a high availability, doesn't matter if it's a native one or customly made with a Zabbix utilities, we need to keep in account like what's our network architecture if we're making like cross data center high availability, which is usually like the ultimate high availability and removing single point of the failure, because having like two Zabbix servers or even three Zabbix servers running like in the same server room is still a big risk, because if something is going to happen with I don't know, let's say with electricity or with the internet in this server room, then obviously it doesn't matter how many nodes we have, we're still going to lose all of them. And also, serious thing is consideration for the costs, because sometimes, especially when some company and businesses decided, okay, they want to invest money in monitoring, and they start with a Zabbix from the scratch, they might have no idea how much like the costs can grow based on their requirements. And by requirements, I usually mean like the size of infrastructure that they want to monitor, what is going to be the average update interval, how often they want to receive a new metrics, and the most important one is like for how long they actually want to keep the history data. Because if we go crazy with all of those numbers and we define our requirements that we want to keep the history data, let's say for 5 years, and we want to pull our items every 30 seconds or something like that, the spending on the hard drives alone just to support the size of the database, what it's going to be with our requirements, are super high. And if we talk about high availability for that setup, of course, like first thing first, it's Zabbix server. And if we talk about a large setup, Zabbix server is going to require like a bit more of CPU power and RAM, definitely. Especially this is affecting database servers, that those are going to be the most expensive. And if we talk about high availability, it means basically taking our cost and multiplying it with number of number of nodes that we want to have in our high availability cluster. We also cannot ignore the maintenance of high availability cluster, which is definitely going to be higher. As I said, like it's not some magic pill from all of the downtimes. You will really need to have some sort of engineers that do understand what is happening in this environment, how high availability is configured, what are potential pitfalls and some mistakes, because things are going to happen. Like even if you have high availability, even if you have some database replication set up from time to time, because of all sort of different reasons, this replication is going to break. Someone is going to need to recover that. If you don't have some commercial services or support or consultancy from Zabbix partners, as example, those are going to be your engineers who need to handle that and unfortunately, it's quite frequently happens that people don't have the required skills to actually deal with those problems. And again, while we spend some hours or even days trying to understand how to potentially fix this high availability setup that we just copy pasted from some online available blog post, and for some miracle, it was actually working for 2 days and now it's broken. It's not going to be an easy thing. And it's very likely that we'll have like multiple days downtime, while instead, if we would have a um, simple single node setup, as usually not going crazy, this would actually be better. But I also don't want you like scare you right from the beginning, because it's also not like that bad all the time, because for high availability, as I said, there are multiple architectures. High availabilities using Linux tools are more complicated. They're more customizable and flexible, and you have much more options. They're also more dangerous. If we talk about a native high availability tools, those are like a bit of more limited on functionality and everything else, but they are more easy to manage. If we have high availability just for the Zabbix server proxies in front end, it's easy. If we have also some clustering and replication for database, again, it is a bit more specific, and that will require some database knowledge. So you always need to wait. What is your requirements? What are your skills available? And how do you plan to actually manage that, not only for a couple of days, but for a future, whenever you will need to upgrade those high availability components, whenever you're going to need to upgrade database. After some time, you're also going to need to upgrade operating system, some distribution. Maybe it's not going to be supported by next LTS version of the Zabbix, but you still will have this high availability solution that you need to maintain. And from all of that, we come to a point when we need to decide, like, okay, but so which components should we actually um, on which components should we use and configure high availability? Because saying that we have HA on our Zabbix is not saying anything. One thing, which is, I would say, probably the most easiest one, is a Zabbix frontend. And with the Zabbix frontend, there is very little that you actually need to keep in mind. Zabbix frontend easily supports active-active setup, meaning that you can have multiple, let's say, Apaches or Nginx setups on different servers pointing to the same database. The only thing that you need to consider is that you need to have a load balancer. So instead of giving to your users like two different IP addresses and saying like, hey, we have high availability. If you want to connect to the node 1, you need to use this IP address. If you want to connect to node 2, you need to use that IP address. Not usually how it works. Usually you have just one IP address, which is being used for all user sessions. And then you have a load balancer, which is actually distributing the load between all of the front end engines that you have in your setup. And a very important case for this is that you need to have, like, load balancers usually have this checkbox is session persistence, which just gonna ensure that if you logged into the front end and load balancer navigated you, let's say, to the node number 1, then until end of your session, you're gonna still remain on this first node without jumping over all sort of different nodes whenever you click any button in the front end. And if we talk about a Zabbix server, which people might think that it's like the most important component to have high availability on, which I, I wouldn't say that it's really true. Zabbix server definitely is important, especially if we're talking about making sure that you have high availability on tools and resources and components that will ensure that you receive notifications and triggers. Like, we don't need a front end for that. If our front end will go down, well, it's bad. People will not see their graphs. They won't be able to configure new items or triggers, but you will still receive notifications. If Zabbix server is going to be down, um, that's a problem. We're not collecting any data. We will not receive any notifications. So basically, nothing will happen. But I personally would say that, like, it's super important to have some high availability tooling on your database because both of those, Zabbix server and database, are very critical, but chances of something going off with a database, I think, are higher than the Zabbix server. And options to recover your database will also be more complicated than recovering if something went on with a Zabbix server. But Zabbix server as such does support only active passive mode, which was always been a topic to critique by users, by some Zabbix customers, and so on. It's always has been true. That's how Zabbix architecture is designed, and that's how it works. You cannot scale by just adding more Zabbix servers to distribute the load. It's not possible. You cannot have a load balancer pointing to multiple servers. You absolutely cannot have multiple active Zabbix servers pointing to the same database. In theory, you of course can do that. You just edit the configuration files and restart the components. But in the reality, this is going to lead to a lot of not good conditions, not good cases, a lot of different problems happening with your Zabbix, and essentially it can even lead to corruption of your database when the only possible cleanup is either restoring from some database backup, and good for you if you have it, not so good if you don't, or the other option is like long running checking of your database, what has actually happened, running multiple queries, and trying to fix everything manually on the fly. Let's say it like that. And if we talk about a database, high availability, it very much depends, first of all, on your database engine. And Zabbix supports definitely more than just one. So you could have MariaDB, you could have MySQL, you could have Postgres, you could have Timescale DB. Each of those could also be partitioned. And each of those also will have multiple ways how you can actually ensure high availability and database replication. You can configure like active passive setup whenever one node is basically not accessible, but it was always replicated against the master. You can have also master setup where replication is like going in both directions. And no matter the database engine, no matter the setup that you have, those are usually not easy things to maintain, especially if you don't have experience, required knowledge, and some training and overall understanding in what exactly you are doing. The best high availability solution always depends on specific situation, engineer skill set, and the business requirements, which I basically already explained in the beginning. Like, make sure that you have a team that can handle high availability. Make sure that if you are that team, make sure that you can handle that. If you just hired some beginner people without any understanding in Linux, without any understanding in a databases and Zabbix as such, it will be very high risk to actually allow them and trust them with making sure that there is some high availability cluster running for your Zabbix. And what tools to use for implementation, again, up to you to choose. If you want to go with more complex setups, giving more flexibility in a way how you can configure that, but also requiring more knowledge, it's definitely the good old PCS, Karasync, or Keep Alive D setup, which are like the standard Linux high availability tools. Those are absolutely not specific to the Zabbix. Those are like designed to keep any service as a high availability. For that, it's also going to require virtual IP management, so that basically same as with the Zabbix frontend, like we cannot have two different IPs pointing to all sort of two different agents and so on and so on. In this case, we would have one IP address, which is just moved to the active node. Like if you have three node cluster from the Zabbix, then whichever is going to be active, that is going to also host the virtual IP address. And basically, if you connect to IP, you will connect to the currently active node. There's also like native Zabbix high availability tools, which is definitely most friendly out of all other options, even without um, some deeper understanding and experience and certification and so on. You can literally configure native high availability options in just a couple of minutes. This is something also we're going to do today in this webinar. We're going to have first of all slides explaining all of the commands that you need to do to make it happen. And I also have a couple of virtual machines prepared with a terminal. So we're going to try to not try, I already have it set up, but we're going to see like what's exactly is required and how to make it happen. Different designs for database replication, as I said, like master-master, master-slave, Galera clusters. Galera tends, at least from my experience, be like one of the most complicated ones. Also, if we talk about the database engines, somehow usually it's easier for people to handle MySQL and MariaDB. I wouldn't necessarily say that reason for that is because those database engines are more easy. Probably I would say it's because there's much more information online, friendly information about setting up a clusters on MySQL. And starting from MySQL 8.0, there's also like pretty much straightforward options how you can configure database replication. Current Zabbix architecture, and by architecture I mean that how the Zabbix is actually configured, where it is sitting. Is it like a physical device? Is it an EC2? Is it a VMware? And that is specifically very important whenever you are having high availability configured with those Linux utilities like PCS, CurrySync, and so on, because how it usually works, like we have, let's say, two nodes of the Zabbix configured, and each of them is checking its current state, whether the Zabbix is up or down. And when the Zabbix is down, okay, it means that our active node has failed and it's time to promote a new active node. So the slave takes over. But since we have this a very rough condition that Zabbix server cannot work in an active mode, we cannot risk that how our slave node detects that the currently active Zabbix is not working, usually just by checking like TCP port 10051, which is running for the Zabbix. But does that really guarantee us if we receive that port is not available? Does that guarantee that the Zabbix server is actually not working? Not really, because there could be some network communication issues between the nodes, which are very critical for high availability setups. Or maybe there are just performance issues where some hiccup on our Zabbix and it is not responding like for 2 or 3 minutes. For us, it is very important to ensure that this node is really down. And how it usually happens is that if we detect that active node is not running currently and it's time to promote a new one, what we do with that previously active node, we send it like to restart. And our Zabbix is configured that services will not start automatically when the server goes to the restart. Services can be started only with a high availability tools. And for that, we usually have like a resource agent, which is responsible to restart those Zabbix server nodes, as example. And resource agent is going to be different for every architecture that you have. Like if you have Zabbix running on the bare metal physical servers, most likely you're going to have some IPMI communication between those to actually send the server to the restart. If you have a VMware or AWS EC2 instances, you will have some API communication with your infrastructure platforms just to make sure that you send the server to the restart. And what I didn't add to the slides, but what is also very important considering your high availability, keep in mind that proper high availability, no matter if we're talking like it's more critical with Linux utility high availability. So PCS, Curse Sync, Keep Alive D, less critical with native Zabbix high availability, and again, very critical with a database replication. Two node cluster is not really a cluster. We need to have at least three nodes just to make sure that we have a quorum, which will ensure that we will not have a split brain situation. And split brain situation in a high availability setup in high availability cluster is a very important problem that can lead to the very bad results. What split brain situation actually means, as I said previously, like if we have two Zabbix server nodes where one is active, one is passive, between them we have the regular link where we monitor whether our Zabbix is up and running and listening to default Zabbix server port. And then we have a different link to our platform, which is going to be like AWS or VMware, which we use to restart. So the issue is that if not our Zabbix server dies, but actually this link between our Zabbix servers, which is being used to monitor the state of our active node, then like slave thinks, let's say this hand is slave, it thinks that, okay, active node has died, let me take over and let me restart it through VMware interface. So we restart the node. This one becomes passive. It restarts, reboots again, tries to check again our second node. And since this link in the middle is broken, it says like, oh, this node is done. So I must promote myself to the active node. And again, I need to restart which previously was active. And what happens is like split brain is that every time our nodes just keep restarting and shoot each other in the head. And this process doesn't stop until we have a proper communication between these nodes. And therefore, like if we have a three node cluster, at least three node, which is a quorum, like this decision that node is down, not is not made by a single communication between two nodes, but between three nodes. It can say like, okay, I don't see the first one, so it's probably dead, but I will check other node, can you see it? So we have multiple link connections between the nodes, which ensure that very likely the issue is really with the Zabbix server itself and not with the network communication. Which brings us like to again question about the costs, because having one powerful Zabbix server, which ensures like front end Zabbix server, Zabbix database is expensive. Having high availabilities is like twice expensive if we have a two node cluster, and having like a quorum, which means at least three nodes, and it could be even more, it could be four nodes, five nodes, is at least three times more expensive. And a solution for that is usually to, especially that's done with databases, is to have a witness node where two of our nodes are powerful specs computers, servers with good CPU, a lot of cores, a lot of memory, good storage, and those are designated to actually run our database for the Zabbix. And then we have a witness, which is just a small machine, which is used only for the quorum, just to check availability of our nodes, and it will never actually host the Zabbix database itself. This is a good trick and thing to do, how to ensure that you have a quorum and you don't need to spend like a lot of the resources on maintaining three servers for our high availability cluster. And always important like to have a shared storage for scripts and other Zabbix assets. And if you don't have a shared storage, just make sure that you have everything that you need for a properly functioning Zabbix on all of your nodes, because If you are used that, okay, I have high availability, but for a whole year, nothing had happened with this setup, and my node one is always an active one. So I have here all my like user parameters and external scripts and alert scripts and I don't know, front-end modules and something else. If failover happens, and a passive node is promoted to the active node, make sure that it also has all of those alert scripts and external scripts and modules and front-end customizations and so on that are necessary for your monitoring setup to function. Next, native high availability methods. So what do we have in the Zabbix for now is Zabbix server high availability, which is available. I believe it's already like starting with a Zabbix 6.0. Zabbix proxy high availability, which is a more recent thing. And this one also supports load balancing called used with the proxy groups. And I will say that this proxy high availability and load balancing with the proxy groups is probably more important and cool feature than Zabbix server high availability itself, because again, back in the times when there were no native solutions for HA, usually the best practice and recommendation was to even not spend your time and resources on setting up high availability for the proxies, because kind of the golden rule was that even if something happens with the proxies, you can like recover them within a minute or two as soon as you get to the SSH or terminal, especially if that is like SQLite proxy. You just drop the database, restart the proxy. It will create a new database, connect to the Zabbix server, pick a new configuration, and continue to work. But since, as I said, like with a PCS, Karasync, and virtual IPs and everything else, it was quite a drama to actually maintain all of that, making your life even more complicated by making sure that you have a same high availability setup on the proxies. And there were multiple additional critical things that you had to remember and do for a proxy high availability. Basically, it was easier to just not do that. And nowadays, you can also use Zabbix proxy memory buffer, which kind of is like high availability for the data storage, where you can, first of all, like store the data in the memory of the proxy to just forward to the server. And you can also store it on the disks, just to making sure that if something happens with the connection and you're unable to send the data, you don't lose it. You have it on the disk, and whenever you restart the proxy or connection is restored, you can actually send it again. So how Zabbix high availability configuration looks like.